this is method 2 for solving the problem. Again, a neater version of the problem is right here, and I rewrote it over here, being a little bit sloppier and dropping the units just because I know what the units are. So these are the same numbers, the batteries have the same orientation, and the configuration of everything is the same. When I'm doing one equation per loop or mesh analysis, what I need to do is figure out how many loops I have. Well, I have 3 basic loops here. I have the left side, the right side, and the whole thing. I just picked 2 of them. Traditionally, I just pick left and right. So what I'm going to do is I'm just going to establish I have a current flowing this way, which I'm going to label I sub D. And I'm going to do another loop over here, I sub E. Notice that there's overlap in the middle. Unlike the method number 1, where I don't have overlap, this method I do have overlap. When I come up with my equations, it is very similar to what before. I'm basically going to do the voltage or loop rule, because again, Kirchhoff has 2 main rules, and I'm using the voltage one. So I pick a spot. Doesn't really matter which spot I pick a starting point, and then I pick a direction. I have 3 loops from which to choose, similar to the other technique. I'm acting like you've looked at the other one already. I have the left side, I have the right side, and then I have the whole thing. And I picked 2 of them. I have 2 unknowns. I only need 2 equations. So I'm going to do my left loop here. So I have 8 going this way. I'm going in the direction of my assigned current right here, minus 3 ID. Now I'm going down through the middle. And as I go down through the middle, I'm going in the same direction as ID, so minus 4 ID. But I'm going against the direction of IE, so plus 4 IE, plus 30, because I'm going from the negative to the positive, and then back over here, minus 6 ID equals 0. I can do the whole or the right. Let's just do the whole. It really doesn't matter which one I pick. I'm going to choose the same starting point. I'm going to go around, come back to here. So I start with 8 minus 3 ID. I'm going in the same direction as my IE here as I go across that 9 ohm resistor, so minus 9 IE, minus 17 because I'm going from the negative to the positive, minus 6 ID as I come back around here, and I'm back to where I started. And I don't think I mentioned this in the other video. Where this is coming from is, I know that for across a resistor, Ohm's law, delta V equals IR. This is the potential drop across the resistor is the current times the resistance, or potential difference. It might be a gain or a loss depending upon which way you're going. So this is just current times resistance, current times resistance, current times resistance. I just happen to draw resistance first. So I have my 2 equations here. I can simplify it. So I have 8 and 30, so I have 38. And then I have 3 terms with ID in it, so that's negative 3 minus 4 minus 6, so that's minus 13 ID. And I'm left with plus 4 IE equals 0. And then over here, I've got my 2 parts right there, so 8 minus 17 is negative 9. And then I have my 2 IDs here, minus 9 ID, minus 9 IE equals 0. I can simplify that further, but I will wait to simplify it.